Hello, sir. So, what are we gonna do today?
So very good evening, my dear children. Am I audible to you guys?
Yes, sir.
Awesome. So today what we'll be doing is we'll be dealing with a new chapter basically. Just a minute. Yep. So today we'll be dealing with a new chapter basically. That chapter's name is indices. Okay. In the previous class, we had completed the previous chapter that was rational numbers. So today we'll be dealing with indices or exponents. So exponents, there goes page number 29. So let me just see and type page number 29 if it can give me the correct chapter. Oh, something is wrong. Yep, I got it. Yeah, here it is. So indices or exponents. So let us try to understand what this chapter is basically. Okay. Now, where is it not moving? Yeah, it's moving. Now, basically, as you can see over here, so we know that, for example, if you're multiplying 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 2, so how many times did you multiply? You multiplied 2 for 5 times, as you can see. Now, when you're multiplying any number, any same number for n number of times, in this case, you're multiplying 2. So this value can be written as 2. How many times did you multiply 2? You multiplied it 5 times. So you can write this number as 2 raised to 5. So this is called as index. Okay. Or and this these like the calculations where such kind of numbers like 2 raised to 5 or 3 raised to 5 or 4 raised to 5 or 6 or any number or 7 raised to 2 or anything like that, these numbers are called as indices. Okay. So the calculation related to them is basically are like this chapter. Okay. And for example, if you are multiplying, this A represents a number, any number it can be. It can be 1, it can be 2, it can be 3, it can be any number. Okay. A is multiplied with same number. If they are multiplied for n times, we can write that expression as A raised to n. Okay. So far, is it clear to you guys?
Yes, sir.
Okay, that's great. Now, there are certain laws while we should follow while we are solving indices. They are called as laws of indices. The first law is very simple. For example, if you have a number like a raised to m, you're going to multiply with another number a raised to n. Okay, then what you have to do, you have to write, see, a is the base, a is the base. You have to write the base as it is a, and the index, for example, for the first number it's m, and for the second number is n. When you multiply them, the indices they gets added with each other. For example, if you have 2 raised to 4 multiplied by 2 raised to 5, your answer, since both of them have 2, it will be 2 only. And this 4 and 5, they gets added with each other. 4 plus 5, your final answer is going to be 2 raised to 9. This is the example of this particular expression. So whenever you see a raised to m and a raised to n, they are multiplied with each other. All you have to do is combine the bases, write 1a, and then simply add the indices. Am I clear?
Yes, sir.
Wonderful.
Yes, sir.
Now, sorry. Okay. If in case if there is any doubt, you simply raise your hand so that I'll understand there is a doubt. Okay. Otherwise, I'll proceed further. Thank you. Uh, a raised to m. For example, now there is now the second law. The first law is a raised to m, product of any two indices with same base. Basically, we have to add. Whenever you see product, you simply have to add over here. Now, in the second case, whenever see similarly, a raised to m divided by a raised to n. Now, when you see division, you have to use a subtraction over here. It's the same process. A you have to write same a raised to m divided by a raised to n can be written as a एक बार लिखना है. Then both the indices you have to subtract. For example, in this case, if you see 2 raised to 2 का बहुत example हो गया. I'll use another example 3. 3 raised to 5 divided by 3 raised to 3. This can be written as 3. I'll write common because both of them have 3. Then this index is 5, this index is 3. I'll simply subtract them. 5 minus 3. 5 minus 3 is 2. I'll write 3 as it is and then I'll write raised to 2. So this will be my answer. So far, so clear?
Sir.
Wonderful. This was the second law. Hmm? ठीक है. Now, the third law is what? For example, again, if you have division like a raised to m divided by a raised to n. So if you're writing in the numerator, you will write it as a raised to m minus n. Like you already know if you're writing in the numerator. But in case if you're writing in the denominator, for example, in this case, 1 upon what they have written is, I'll just write it again over here. What they have written is a raised to n minus m. So what I'm trying to say, whenever you take a number from numerator, whenever you take a number from numerator to denominator, you simply have what you have to do is you have to exchange them whenever they are in subtraction. In case they are in subtraction, they you have to exchange them. Do you understand?
Sir.
Okay. Whenever this is called as reciprocal. Okay. So what happens, logically speaking, I'll tell you what happens. Logically speaking, for example, if you have a raised to n over here, the reciprocal of a raised to n is a raised to minus n. So what happens over here, when you take the reciprocal, you basically introduce a negative sign. Over here also, you have done the same. Technically speaking, you have done the same. I'll explain. So what happens, over here also, a raised to m minus n, when you take reciprocal, you basically introduce a negative sign for m minus n. Okay. Now this negative sign is common for both. Now when you open the bracket, this negative sign combines with m becomes minus m, and this negative sign combines with minus n to make it plus n. So in the next step, what happens? It becomes minus m plus n. And then when you rearrange the terms, it looks like this: a raised to n minus m. I hope this logic is very clear.
Yes, sir.
Yeah. So I'm just giving you the
Excuse me,
logical
sir.
explanation. Yes, please tell me.
Sir, can you please give an example because m is greater than n and m is less than n. So in the second and third one. So
Sure, I'll
for
give you
that,
an example, not a problem. Naitik,
thank
what
you.
was your query?
Sir, in the second one, we directly did a raised to power m minus n, but
Yes.
we took reciprocal of that
Mhm.
is smaller than n. That is the reason, no? Because if we don't take reciprocal, it will be the power will be negative.
Yes, see, a simple logic, my dear child. It's like irrespective. In this case, I'm just telling you, whichever value is greater, don't think about that. कि कौन बड़ा है, कौन छोटा है, don't even think about that. Simple logic, every time you have to do the subtraction. Ha, if m is greater than n, then this value will be a positive value and this value will be a negative value. If it's the other way around, then this will be a negative value and this will be a positive value. So I'll now give you an example just to make things clear with you. Don't worry.
Okay, sir.
Yeah, I'm just erasing this. I'll just take a random example. Okay. So don't worry about where positive will come, where negative will come. It's okay. Doesn't matter. In case of laws of indices, it actually doesn't matter. Okay. But while writing final answer, maybe we'll have to make some arrangements that I'll discuss later. Okay. While solving the problems, I'll discuss those things. Okay. Now, in this case, yes, definitely when m is greater than n, it's better to use this. Why? Because simple logic here, m is greater than n मतलब index के ऊपर positive sign आता है. Yes, we prefer to have a positive sign in the index, but in case if we don't have a positive sign, you can simply take a reciprocal. For example, I'll use 2 raised to 5 divided by 2 raised to 2. This answer can be written as 2 raised to 5 minus 2. That is 2 raised to 3. This is one thing. Okay. Now, if I take a reciprocal of this, what will happen? It will become 2 raised to minus 3. Now, both are correct answer. This is also correct answer. This is also correct answer. But the thing is, when you see a negative sign, you are not so comfortable with negative sign. So what do you think? अरे नेगेटिव साइन को अगर अवॉइड कर सके तो अच्छा रहेगा. इट इज बेटर फॉर अस टू अवॉइड द नेगेटिव साइन. So in that case, even though both are correct, you will prefer this one. Am I correct or not?
Yes, sir.
Yeah. Similarly, if your number was like this, 2 raised to 2 divided by 2 raised to 5. Now, when you try to divide them straight away, okay, so what will happen? It will become 2 raised to 2 minus 5. That will give you 2 raised to minus 3. Now, that if I take a reciprocal of that, that will give you 2 raised to plus 3 in the denominator. Now, again, this is also correct and this is also correct. But since this is having a negative sign, we are not so comfortable with it. So we will prefer this one to be our correct answer. Final answer. Do you understand me?
Yes, sir.
Now that is the
Yes,
reason why
sir.
they said if m is greater than n, it is better you use this format. If m is less than n, you better use this one. Whereas both are correct only. Nobody is wrong. It's just our comfort zone. Okay. Yes, Naitik, tell me.
Sir, so we don't say like that, no? 2 raised to power minus 3 or 1 upon 2 raised to power 3. Which one of them is a simplest form? Both are simplest, right?
Yeah, both are simplest. See, when you go to the higher grades, you will observe that both are simplest. It doesn't matter. 2 raised to minus 3 also doesn't matter. 1 by 2 raised 3, 2 raised to 3 also doesn't matter. So when you will automatically observe that in higher grades, sometimes you use this, sometimes you use this. It doesn't matter. Both are having equal weightage. Okay?
Okay, sir.
Okay, that's great. Now, for the fourth one, I'll do one thing. I'll zoom this one for you. थोड़ा सा zoom कर लेता हूँ, just for your sake. Okay, why am I not able to zoom here? I'll use this one just to make your visibility better because these texts are really small. Okay. Now the next one. The next one goes like this. It's like you already have a raised to m. Now उसके भी ऊपर n. Now index का index. You already have something उसके भी index. So both are index. So this is also an index and this is also an index. Index का index है. So in that case, what you are supposed to do is you simply have to multiply them. For example, let me say 4 raised to 2 you already have, and the whole raised to 3 you have. In that case, what you have to do is 4 raised to 2 multiplied by 3. That's it. So par ka par, you have to multiply. Then your answer becomes 4 raised to 6. Am I clear?
Yes, sir.
Wonderful. Now, the next rule is what? Fifth rule. It's like, for example, if you have two bases, two numbers multiplied with each other, having a common index, then you have to distribute the index to both the numbers. This index is for both of them. Like, for example, let's say 5 multiplied by 3 raised to, let's say 2. Now, this 2 should go to 5 as well as 3. So your answer goes like this: 5 raised to 2 multiplied by 3 raised to 2. Do you understand me?
Yes, sir.
Wonderful. The same thing goes for division as well. By the way, this symbol is an error. It's not a division symbol. It should be an equal to symbol. The same thing goes for division as well. Just like how multiplication with the if two numbers when multiplied with each other are having a common index, that index can be distributed to both of them. Similarly, in case of division also, if two numbers are divided with each other and you have a common index, this index belongs to both of them. So, when you write equals, it's basically a raised to m and divided by b raised to m. For example, let's say 5 upon 3 raised to 2 it is. In this case, you can write this as 5 raised to 2 divided by 3 raised to 2. It goes to both. Clear?
Yes, sir.
Yeah. The next rule is what? Any number raised to 0. This is very important. Any number raised to 0 is equal to 1. Any number. You say 2 raised to 0, that is equal to 1. You say 3 raised to 0, that is equal to 1. You say 1123 raised to 0, that is also equal to 1. So any number is raised to 0 is equal to 1. Am I clear?
Sir.
Wonderful. Then any number raised to 1 is basically reciprocal. For example, if you have 500 raised to minus 1, then it is basically 1 upon 500. That's it. Okay.
Sir.
And this one I had already discussed before. Like, for example, you have 4 raised to minus 3. You can write it as 1 by 4 raised to 3. Or if you have 4 raised to 3, you can write it as 1 by 4 raised to minus 3. So whenever you do reciprocal, there is an addition. Basically, there is a toggle of minus sign. If there is a minus sign, it will be removed. If there is no minus sign, it will be added. Whenever you do reciprocal, it happens. Am I clear?
Yes, sir.
Yeah. Just give me a minute, my dear children. Yep, my dear children. I believe I'm audible.
Yes, sir.
Okay, that's
Yes.
great. ठीक है. So now we are very well aware of the laws of indices. So these laws we have, which we are supposed to follow while we are going to solve the problems. Okay.
Sir.
One thing you should remember. See, there are certain things which we should keep in mind. Uh, 0 upon 0 is generally not tolerated. Okay, we never do 0 upon 0, and 0 raised to 0 is also not tolerated. Okay. So 0 raised to any number is okay, but 0 raised to 0 is not allowed. Well, these are the certain calculations which are, very complex, which you will be dealing when you will be, you should go beyond 10th, beyond your 12th also. So when you will do degree courses, that time they'll teach you how to deal with these numbers. For now, you should observe that over here, that's the reason why they have mentioned that a should not be equal to 0, because 0 raised to 0 is a very complicated answer. That answer we cannot discuss at this stage. That will be taught to you maybe after 10 years. After 10 years. Okay. In the higher studies, you'll be taught. Yeah. Now, this is another rule. Like, basically, this I've already taught. Basically, a raised to m and a raised to minus m are reciprocal or multiplicative inverse. So, in short, a raised to m ka reciprocal is a raised to minus m, and a raised to minus m ka reciprocal is a raised to m. Iska example I had given. 2 raised to 5 reciprocal is 2 raised to minus 5, and 2 raised to minus 5 reciprocal is 2 raised to 5. Yes, Naitik, tell me what's your doubt?
Sir, means in the above one you said 0 raised to 0 or any number upon 0. So we said that not at this level, we say not defined or infinite.
Hmm. Okay, I'll just give a clarity on that. This much is clear, right? I can erase this. Am I correct? Rishik,
Yes, sir.
is your if your query is related to this, then let me know. Otherwise, I'll erase this and then I'll solve a Naitik's query.
No, sir. I had a doubt which chapter are we doing because I just joined.
Okay. We are dealing with the next chapter, my dear child. The chapter's name is indices. It's the fourth chapter.
Oh,
Okay.
got it.
ठीक
Thank
है.
you, sir.
Now I'll tell you the rules basically. Sorry, just give me a minute here. Okay. So see, I'll tell you basic things. 0 upon 0 is not defined. 0 raised to 0 is not defined. And any number upon 0 is infinite. You know the symbol, right? It's infinite. You write this down. Meanwhile, give me a minute. I'll just be back. Yep. Rishik, tell me.
0 raised to the power 0 is not defined. Isn't it supposed to be 1?
No. See, that's why I said when I in the law also it is written any number raised to 0 is 1. But that law is not applicable for 0 raised to 0. It's written over there. I'll show it to you
Is
just a minute.
it applicable? Like,
Yeah. See. Uh yeah. A raised to 0 equal to 1, where A should not be equal to 0. A can be minus 1, A can be plus 1, A can be minus 100, plus 100, any number it can be, but A should not be equal to 0. That is the only condition. Okay.
exactly why only 0 is an exception.
That reason, to know that reason, you'll have to know maths in very detail. So this reason also will be given to you only at least after 10 years. You'll have to learn that much of math. Then only you will be able to understand the reason.
Okay, so then I don't understand why 0 upon 0 is not defined. Shouldn't it be 0?
Again, the same reason. Okay, I'll just give you क्या बोलते हैं उसको, a brain teaser. Okay, I'm not going to give you a solution, but I'll just give you a brain teaser just to make it interesting. 0 upon 0, okay, I'll tell you one thing. There is a rule कि भाई any number upon any number should be 1. So with that rule, I must say that 0 upon 0 should be 1. Now there is another rule that 0 upon any number should be 0. With that rule, this 0 upon 0 should be equal to 0. Now there is another rule that any number upon 0 is infinite. With
Right.
that rule, this 0 upon 0 should be infinite. So this is a fraction which can have three possible answers. And that is the reason why I'm telling you it is not defined for you guys. Okay. Now, such kind of situation, how to solve such kind of situation, that they are taught on a very higher grade. After 12th standard, you will have to do special degree courses in mathematics. So, special mathematicians, the scientists, those guys deal with such kind of problems. This problem, this problem, this problem, all these problems. Not this one, only this one. These two problems, not defined problems. Okay. So right now, you won't be able to apprehend the logic behind it. Okay.
read also about A upon zero. So I searched on the internet, and every site that I searched on, it said that zero, anything upon zero is not defined. It isn't infinite.
It is not defined, as I've already told you. Anything upon zero is defined on higher grades. On higher grades, it is defined as infinite. Matlab, you will also learn about these maybe in 1 or 2 years. Maybe you'll learn about this also. What is infinite and all? Maybe 1 or 2 years.
So that it was not infinite.
Yeah, till then, so till 8th standard or maybe ninth standard, it is not defined. But immediately, as soon as in couple of years, teachers will teach you, my dear child, this is not defined. It is defined as infinite. Understood? And don't believe on websites. Basically, website में कोई भी डाल सकते हैं. समझे? I'm
Because
not
there were
saying
like 5 websites saying that.
हाँ, I'm not saying that the जिसने भी डाला होगा वेबसाइट में they are wrong. I'm not saying that they are wrong. It depends on what kind of audience are they targeting. Okay, anything upon zero क्या होता है? Who might ask? Obviously, students like you who don't know what is anything upon zero, they will only ask in the website. So they know that small children are asking. So when small children are asking, if they are saying that the answer is infinite, they will have to explain what is infinite. Hence, what they will say, Arey, I'll tell, it is not defined. Khatam. Because they know that in your textbooks, it is not defined. Understood?
Okay.
Yeah. Yes, Krithvi, tell me.
Yes, sir. So A upon zero is infinite, but then zero upon A is not defined, right?
0 upon A is 0. I have written over here.
It is.
Here.
Oh, okay.
0 upon any number is 0.
Okay, thank you.
Yeah. So anyway, so we are deviating from the topic. Let's not deviate from the topic. I just gave you these informations because these are few extra informations which you might learn only after a couple of years. Okay. So I'm just giving you just to spice things up. Okay. Not to confuse you guys. So if you're feeling यार एक confusion है, then ignore क्योंकि वैसे भी वो syllabus का है नहीं. Just spicing things up. Okay. Now let's proceed. Now, how to write square root in terms of index? So whenever you see square root, what is square root? It is basically square ka ulta, as you know. So square, how do you write square? Give you a simple example. Let's say, ha, A is equal to B square. For example, I'm telling you, let's say A is equal to B square. Now, when I take the square, that is this 2, to the other side, it becomes square root. Square root of A is equal to B. It becomes like this. I hope this much is clear for everyone, right? सबको पता है ये चीज.
Yes, sir.
Very good. Now, what happens when I take this 2 to the other side? उसको मैं एक और तरीके से लिख सकता हूँ. I can write this in one more angle. If A is equal to B square, since I'm taking this 2 to the other side, what I'll do, I'll make it 1 by 2. When I take 2, it becomes 1 by 2. That's it. With the same logic, if you think, yes, Naitik, tell me.
We got square. So if we move square to the other side, or the square root to the other side of the equal to sign, we get square or square root. Means if it is square, then we get square root. So
Hmm.
this is based on logic, or there is any proof?
They are called as inverse operators. Like multiplication and division, they are inverse operators. वैसे ही square and
Okay.
square root, they are inverse operators.
So
समझे?
cube and cube root are also inverse.
हाँ. Like how addition and
Okay.
subtraction.
So
Addition,
okay,
subtraction, they
it's a
are
law
inverse.
type.
Law, yeah, yeah. For every action, there is a reaction. If square is an action, square root is its reaction. मतलब हर चीज को हम बढ़ाएंगे तो
Okay,
उसको
sir.
कम भी करने को आना चाहिए. Like that.
Okay, sir.
Okay?
Okay, sir. Understood.
Yeah. So when I take cube this side, I'll write it as 1 upon 3. It's basically cube root only. I can also write this as cube root of it. Okay? Both are same. So hence, in short, I was saying Square root can be expressed as raised to 1 by 2. Cube root can be expressed as raised to 1 by 3. Nth root can be expressed as raised to 1 by n. So even the law इतना ही बताता है, मैं आपको उसका लॉजिक बता रहा हूँ कि वो क्यों 1 by है, क्योंकि जनरली ओवर हियर वो इंडेक्स में इट इज इन न्यूमरेटर, so when you take it to the other side वो इंडेक्स में ही रहेगा, but it will go to the denominator of the index. You know that, right? For example, a multiplied by b is equal to 1. When you take b to the other side, what happens to b? B will go to the denominator. Same चीज मैंने यहाँ पर किया है. When I'm taking one number from index on one side, when I take it to the other side, वो न्यूमरेटर से डिनोमिनेटर में जाएगा. That's it. खत्म. Any doubt?
No, sir.
Great.
Mm-hmm.
Now, third point. A raised to m upon n is expressed in two ways. Now, let's see what kind of two ways. Now, logically speaking, what is this m upon n? So, whatever is in numerator, वो that is par basically 2 रहेगा तो it is treated as square, whereas whatever is in denominator it is treated as root. If it is 2 it will be treated as square root, if it is 3 it will be treated as cube root, and so on. So denominator is basically for root and numerator is basically for the par. Okay, par or power. Now, this can be treated as, so m upon n can be written in two ways. So I can write this as m upon n can be written as m multiplied by 1 by n. This is one option to write. Or I can also write it as 1 upon n multiplied by m. दोनों correct है. Okay. So I can take m first and then I'll write n by n, or n by n 1 by n first and then I'll write m. So the first option is what? I'm taking m first. So I've taken m first and then I've put a bracket and then I've written 1 by n. It's par ka par. Or I can take 1 by n first and then I'll put a bracket and then I'll write m. And both are one and the same. Okay, this is not a plus sign. This should be a arrow sign. Now, if I'm taking the first approach, a raised to m raised to n by n. So सबसे बाहर कौन है? It is 1 by n. 1 by n means what? Nth root it is. So the sentence goes like this. जो सबसे बाहर है वो सबसे पहले लिखना है आपको. It is nth root of, उसके अंदर जो है, then you have to write that mth power of, उसके भी अंदर कौन है? A है. A. So this should be the sequence. There are three things. सबसे बाहर कोई तो है, उसके बीच में कोई तो है, then सबसे अंदर कोई तो है. Over here, how will I start? सबसे बाहर is m. I'll say mth power. And उसके बाद 1 by n. Then I'll say nth root. बीच में off डालना है. Then again off डालना है. Then I'll say a. This is the structure how we form a sentence. Am I clear?
Yes, sir.
Wonderful. So, our time, like, हमारा time खत्म हो रहा है. Let's do one thing. Let's exit the meeting and join again. Okay.